in this problem, we're told the acceleration of a bus is given by a sub t, which equals alpha times t, where alpha equals 1.8 meters per second cubed. If the bus's velocity at time t equals 1.14 seconds, is 4.9 meters per second. What is its velocity at time t equals 2.1 seconds? If the bus's position at time t equals 1.14 seconds, is 5.91 meters. What is its position at time t equals 2.1 seconds? And I'm not going to do c. You can do c on your own if you want. So the first thing that we want to do is write down what our acceleration function is. And they tell us it's alpha times t, and alpha is 1.28. So just plug it in, right? Plug in the numbers. So 1.28 t. And so what we're trying to do here is find the velocity and find the position at certain times. So what you want to do is, if you remember from calculus, if you take the integral of an acceleration function, you'll get velocity. And if you take the integral of a velocity function, you'll get position, right? So that's what we're going to use to solve this. So let's take the integral of our acceleration function, and that's going to help us solve for a. So v, if you take the integral of this, it's going to become 0.64 t cubed, right? Because you add 1 to the exponent, so it'll become 2, divide by it. So 0.64 t cubed, and then it's going to add the constant. You have to add the constant. And so they tell us in this problem that at t equals 1.14, it's 4.9 meters per second squared, right? So at 1.14, 4.9 meters per second squared. And we're going to use that to solve for c. And then once we have c, we can just take the time that they want us to find the velocity at, and we can just solve. So we need to find c first. So let's plug this in first. So we know the velocity is 4.9 when this is 1.14. So 0.64 times 1.14 squared plus c. If you go ahead and do this, you're going to get 4.9, and these are just going to be estimations. I'm not going to use the full value, but it's going to be 8.317 if you square this, right? Or add that and square it, or multiply and square it. And then what we want to do is solve for c, so minus 0.8317 from both sides. 4.9 minus 8.3, or 0.8317, you'll get 4.0683. And so that's going to be your c value. So we're just going to take that value, plug it in for c, and then we can actually solve for, or we can input the time to solve for velocity. So it's going to be 0.64 t squared plus c, which is 4.0683. And so we're trying to solve it at t equals 2.1 seconds, so plug that in. If you go ahead and do this, 0.64 times 2.1 squared plus 4.0683, you'll get about 6.89. So about 6.89 meters per, or it's just going to be, yeah, meters per second, because that's the units for velocity. So that's going to be your answer to A. And let's move on to B. So B is going to be position. We're trying to find the position at a time. So remember how I said if you take the integral of acceleration as velocity, so if you take the integral of velocity, you get position. So this is our velocity function. V equals 0.64 t squared plus 4.0683. We're going to take the integral of this and get position. So the integral of 0.64 t squared is going to be 0.213 t cubed, right? Because you add 1 to the exponent and divide by that, divide by 3. And then 4.068 t, because when you take the integral of a constant, you just get that constant times the variable. And then plus d, which is our constant, right? Just as we added c in this one. And so what we're going to want to do is plug in the position, 5.91, at 1.14, solve for d, and then we have d, and then we can actually just solve by plugging in a time. So let's do that. So 5.91 equals 0.213 times 1.14 cubed plus 4.0683 times 1.14 plus d. So 5.91 equals, if you go ahead and do this right here, this whole part, you'll get 4.953 plus d. And then if we minus this from both sides, if you do that, 5.91 minus 4.953, you're going to get it equals, or d is going to be equal to, right? Because d's just left. It's going to be 0.947. So that's going to be that. We can plug this back in for D and solve for the position. So x equals 0.213 t cubed plus 4.0683 t plus our D 0.47. And so we're trying to find it at time 2.1. So just plug that in. X equals 2.13 times 2.1 cubed plus 4.0683 times 2.1 plus 0.947. So if you do this, you're going to get, here, let me see. You're going to get like 11.46. I'm just going to round it. So you'll get like 11.46. You can leave it like this. You can round however you want if you want to do that. And then keep in mind the units are going to be in meters because this is position. So yeah, this is going to be your answer for B. If you want to do C, you can go ahead and do that on your own, but I'm not going to do it here. And then this right here was your answer to A, and hopefully you found this video useful.